Hi, this is Cygnus X2, a 3-rod carbon fiber rocket. This is a thrust vectoring model rocket, and I built it after the first one had a little bit of an explosion. This one is opened, so this is how it's going to fly. There's not going to be any cover on the outside to protect it, no aerodynamic sort of cover or anything. This is its final form. One of the reasons why it's open and it has carbon fiber rods is that it's much more easier to mount things onto and modify and fix if there's any problems. Another reason is that this is, obviously very visible. Like, you look at this and you say, oh, doesn't look like a rocket, but it looks really interesting, right? So it's sort of a way to, I guess, capture people's imagination, or to show that this isn't just a typical rocket. When people see this, they start asking questions, and then you sort of learn more that way as well. And also learning is sort of the third part, is like, I can much more easily explain what's happening with the rocket if I can show the insides of the rocket just right then and there at the launch pad, right? So speaking about the insides of the rocket, let's go and talk about the three main sort of sections. So the first section is the thrust vectoring gimbal. So this is the thrust vectoring gimbal from my old rocket, and it has a new 3D printed part on it because the old one exploded, and it's got a mount at the top to mount extra things like sensors and stuff. I was originally using it to mount an angle sensor, or just like another IMU at the top here to sense exactly how much the TVC gimbal is actuating. This would be good for zeroing out the TVC gimbal automatically. Next is the middle portion, and this is actually the flight computer right in the middle here. And the flight computer, it is basically the same flight computer as before. I had to fix a few things in the flight computer. Some connections sort of got disconnected when everything exploded from the last rocket. But other than that, this flight computer works fine. It's got the battery on the back here. And yeah, that's mainly it. I'm going to do probably another video soon on the flight computer to speak about more of the details on it and how it was designed and all the components that went into it. To the flight computer, we have obviously we have the TVC, the two TVC motors, the stepper motors, going into the flight computer with a PWM signal. And we also have, above the flight computer, there's a new section that I added that wasn't on the old rocket. And this new section is a GPS antenna, or a GPS module, and a secondary IMU. The secondary IMU is a Bosch BNO055. The reason I'm using this secondary IMU is because it has a magnetometer on it. The IMU in the computer does not have a magnetometer on it. And these two sensors, the GPS sensor and the Bosch IMU, those are going to be used to run a Kalman filter that will be able to figure out which way the rocket is drifting. The reason you need a magnetometer is because it will be able to tell me which way the rocket's pointing, north, east, west, south. And then using the GPS coordinates, I can figure out where the rocket is with GPS, and also fusing the accelerometer measurements from either of these accelerometers. Right now for this first flight, I'm just going to be gathering data. I'm not going to be like calculating anything from it or doing any Kalman filtering. It'll just be gathering data, seeing what I get out, seeing if the GPS chip is worth anything really. This is like a cheap one I got from AliExpress. Hopefully it'll be accurate enough. We'll see. And above that is the parachute actuator. So this is a purely mechanical parachute actuator using two rubber bands and a servo motor to latch and unlatch a rod. And top of the parachute section houses the actual parachute. So the parachute sits inside here, and there's like it basically is like a piston, and the nose is up here. I've just taped it to the top. And the parachute isn't inside right now, but you can see on the inside sort of there's a little cup here that would hold the parachute. And yeah, when this parachute mechanism gets pulled down, it latches, and then it is ready for deployment. So let's talk about some of the, I guess, yeah, so what about the weight, right? So what about the weight and the differences between this rocket and the other one? So this rocket right now, fully loaded with a motor and everything, ready for flight, is about 950 grams or so. The old rocket was about 750. So this rocket won't be going as high. The old smaller rocket, that on an F-15 motor, that was estimated to be able to go out to about 90 meters in height. This rocket at 950 grams is estimated to go to about 58 meters, so much less. And you can sort of see, you know, we've added only 200 grams, but we're already losing almost half of our height. And the reason that's so heavy is because I added these sort of sections here to sort of adapt the old mounting points for the old components to a sort of wider frame here. I probably, in the future, I'll probably redesign these mounts or actually incorporate the carbon fiber sort of mounts in the actual components or in the actual original sort of pieces. So the rocket will be a little bit skinnier, and so there'll be less plastic. Also, another reason is probably because I had my infill for these 3D printed pieces was a little bit high. I sort of wanted to err on the side of caution. Another new thing on this rocket is heat set inserts. So for these sections here where the 3D printed plastic mounts to the carbon fiber rods, I have a heat set insert in the plastic, and I've got a screw that screws into the insert and squeezes against that rod to keep it tight. They do add a little bit of weight though, but the amount that they add is not that much. It's only about like 4 grams or so extra, which is not that much compared to how much I can shave off from other components. Anyways, yeah, so thanks for watching.